Okay, so today we're going to be dividing polynomials, and we will apply why we're learning this in a later lesson. So today it's going to be like, well, yeah, I get why we're doing this, and how does this really apply to us, but that's a whole different day. So we've got to learn this to be able to apply it. So we're going to be dividing polynomials by using two different methods, long division and synthetic division. So we're going to first learn how to divide polynomials using long division. Okay, so long division is just it's just a method to divide a polynomial. So you can divide, remember back to I don't remember what grade, but when we did long division with just numbers, so if you look at just this, they did long division and got 32. Anyways, you can divide polynomials using the same process for long division, pretty similar. So I don't know if I want to read all this. Let's see if there's anything I can say that's super important here. All right, so one thing I do want you to know, if you go through and take 672 and you divide it by 21 and you divide it down and there's a remainder of 0, then 21 times 32 were factors of 672. Factors mean what multiply to be it, correct, everybody? Okay, so there's a couple words that you will want to note here. So this is called the divisor, what you're dividing by. So this 2x plus 1, if I ever say to you the divisor, it's what you're dividing the polynomial by. This is the polynomial. We're dividing 6x squared plus 7x plus 2 by 2x plus 1. That's the divisor. And what you get is called the quotient. So once again, and we'll go through how to do long division in just a second. But if we take 6x squared plus 7x plus 2, we divide it by the divisor 2x plus 1. We go through the long division process, which we'll go over in a second. If we get a remainder of 0, then this went into it evenly, meaning 2x plus 1 times 3x plus 2 multiplied to be 6x squared plus 7x plus 2. Does everybody understand that? We haven't got there yet. I'm gonna go over that in just a second. So right now, we just need to understand if our remainder is 0, then this was a factor, meaning this times this equaled this evenly. Does that make sense, everybody? Okay, we'll go over how to do the long division process in a second. Okay, so then also notice one more thing. 6x squared plus 7x plus 2. If we take a quadratic and divide it by something linear, 2x plus 1, we're taking x squared and dividing by x. So our answer is going to come out 1 degree less than x squared because we're taking it down 1 degree. So do you see how it came out linear, degree 1, after we divided a square by a linear? Came out degree 1. So that'll always be true. So if we took a cubic and divided by a quadratic, it's going to come out degree 1 because 3 minus 2 is 1. Does everybody understand? 1 less than what we started with. Yes. I'm trying to think. I'm trying to think. Let me think about that. The rational, we will learn the rational. I'm trying to think of how that would relate. You might be on to something. I just can't think right now. So maybe not. I'll get back to you on that. I'll think about it. It might hit me. Okay. So here we go. This is how long division works. Oh, well, first of all, I want you to look up here to make a point here. If we did have a remainder, this is what happens. So if I said to you 7 divided by 2, if we take this 2, put it on the outside of the house, 7. So 7 divided by 2 is 3, right? 3 with the decimal, or remainder. So it only goes into it 3 times. Okay, interesting. So then 3 times 2 is 6. We change the sign, add straight down, we get 1. That's our remainder, right? So what this means is 2 times 3 is 6 plus the remainder 1, which is 7. That's how it works if we have a remainder, right? Sorry, that's my fault. Annoying. Sorry about that. I keep having, what do they call it? Anyways, okay, so we understand that we would take our remainder and add it, correct? To get to 7. Okay, sweet. So here we go. Now, long division, you've just got to learn the process. So are we ready to learn the process? You kind of just got to be okay with learning a process, not like getting caught up in like the logistics of it. because the logistics are very logistical over here if you're interested. All right, here we go. So just learning the process, and that's why we're not going to get into the logistics because it's pretty messy, but if you want to, we can. Anyways, here we go. Number 5, it says take x squared minus 3x plus 1. We're going to divide it by x minus 4. So what we do is just learning the process. We go to the side. We set up x minus 4 on the outside of the house, I call it. So x minus 4. And then we're going to be dividing. So we're going to take this polynomial, x squared minus 3x plus 1, and we're going to divide it by x minus 4. So with division of polynomials, you focus on the leading coefficients, that's it. Okay, so we're going to go off to the side. I always like to show bulletin points to show my work, just little like in steps. So I go off to the side. We focus on leading coefficients. So we're taking x squared. We're dividing by this leading coefficient x. We're just focusing on the leading coefficients. Is everybody good so far? Yep. Nope. Let's keep going, and it's going to make sense. Here we go. So we're just focusing on leading coefficients right now. X squared divided by x is x. So that's what goes on top. And I'm going to line it up with my x's just to keep things nice and tidy. So we have an x when we divided x squared over x. And now, so we kind of went off to the side, we put it up, and now what we're going to do is take that x, and we're going to multiply it back down here. X times x is, let's line it up, x squared, but now we have to multiply x to that as well. So x times negative 4. Negative 4x. Is everybody comfortable with how I distributed that back in? Now here's the thing. We want our x squareds to go away, to cancel out. So we've got to change our sign. But we can't just change the sign on this. We're multiplying by negative 1. So we're going to just change this sign, and we have to change this sign. Is everybody good so far? Now we're going to add straight down and see what's left underneath the house. X squared minus x squared is 0. Negative 3x plus 4x is x. Correct? And then we have a plus 1 left. Is everybody good so far? So now that's what's under our house. And now the process starts over. We go off to the side, and we focus on the leading coefficients. So we're going to take our leading coefficient x under here, divided by that leading coefficient. What's x over x? 1. So now that's what goes back on top. It's positive 1, so we put plus 1. And it's just the same process. So does everybody see how it's a circle? I call it, like with my regular kids, we're going in a circle. We're not done. Yep, so we're not done yet. But is everybody good up to here? Okay, just making sure I'm not going too fast, so I'm pausing. Okay, now we got to do this again. 1 times x is x, correct? Positive 1 times negative 4, negative 4. Now don't forget, we need these x's to cancel out, so we're going to multiply the bottom by negative 1. So that's negative x, positive 4. And now we're going to add straight down to see what's left under our house. The x's become 0, 1 plus 4 is 5. So now 5 does not, if we're focusing on leading coefficients, 5 doesn't divide by x, correct? So we're done. That's our remainder. So we have x plus 1 with a remainder of 5. So once again, we got a remainder. So these were not factors necessarily. They didn't multiply to be that, right? Otherwise, our remainder would have been 0. But we can always divide something. We can divide 7 divided by 2, even though it doesn't go into it evenly, right? So do you understand how we do this? Okay, so this is how we're going to write our answer. We're going to say when we took this polynomial divided by this polynomial, we got x plus 1 with a remainder of 5. So we really add our remainder, so plus 5 out of x minus 4. So this is how we would write our answer. Now, some people get bugged by the, why you have to put the x minus 4. But it's because if we just put plus 5, then wouldn't we have got x plus 6? which is not what we got. It's 5 out of x minus 4. Now, if you don't believe me, or if that's bothering you, I showed you the math of y over here, but I'm not going to spend too much time going over that unless you're super interested. Does that make sense? So if you don't care, then let's just go for it. If you're interested after class, you can come go through that with me, okay? All right, any questions so far? Let's practice again. Everybody good? Okay. Number 6, here we go. 5, I believe, yep, 5. Okay, number 6, so we set up on the outside of our house our divisor. So we're gonna go x plus 2, and then under our house is x cubed minus 4x squared plus 3x plus 2. So we're focusing on the leading coefficients. I go off, I do my bulletin points, that way I can check your work really well. So I'm focusing on my leading coefficients, so x cubed divided by x squared. Now that's what comes up on top, let's line it up. We got an x squared. Everybody good? So we're doing our circle. We're going to distribute that through, ding ding. X squared times x is x cubed. X squared times positive 2 is plus 2x. Is everybody good? 2x squared. Now we have to change our signs. Negative, this was positive, so now negative. And now we add straight down. X cubed minus x cubed is gone. Negative 4x squared minus 2x squared is negative 6x squared. Plus 3x is still there. And then plus 2. And we're doing our circle again. We go off to the side, focusing on the leading terms. So we have negative 6x squared divided by x, which is negative 6x, correct? That's what goes back on top. So we have minus 6x. And we're back to our circle. Oh, I'll get it in a second. So negative 6x times x is negative 6x squared. Negative 6x times positive 2 is negative 12x, correct? We've got to change our sign on both of those. And we add straight down. Negative 6x squared plus 6x squared is gone. 3x plus 12x is 15x. And then we have still plus 2. And we're back over to the start here. 15x divided by leading coefficient x is positive 15. That's what goes on top. And we're back to the distribution. So 15 times x is positive 15x. 15 times 2 is 30, positive 30. Then we change our signs. And we add straight down. 0, x's, and then minus 28. Oh, that's our remainder. Okay, so we have a remainder of negative 28. So when we took this polynomial divided by this polynomial, we got x squared minus 6x plus 15, and then we got negative 28, so we're minusing 28 out of x plus 2. So I'm going to ask you again, was x plus 2 a factor? No, our remainder wasn't 0, but we can still divide it, so we're doing good. Okay, so what I was saying, some of you kind of looked confused still. We took degree 3, we divided it by degree 1, we got degree 2. You see how it's smaller by 1 degree now? So that's what I was saying. Everybody good? You ready to just practice it yourself? Yeah. Okay, sweet. Do 1 through 6. Something. You can always use long division to divide any polynomials. So we could use, if on an ACT, they said, for example, x cubed minus 2x squared plus x, and we were dividing that by x squared minus 1, for example, it's the same process. You just focus on the leading coefficients. Does that make sense? So even though this isn't linear, it's the same process. So that's when we'll use long division. Otherwise, if this is degree 1, from here on out, we'll use synthetic division, which we're going to learn in a second because it's way quicker and easier. Okay, so I'm not going to go through this because we've already talked about it and you understand it. what this is saying, and it looks really big and crazy, but all it's saying is, so the division algorithm says, if you take a polynomial p of x and divide it by d of x, and you go through, you'll get a remainder. If your remainder is 0, then d of x times q of x is p of x, which makes sense. We've already talked about that, right? Otherwise, p of x will be d of x times q of x plus the remainder. Everybody good with that? Sweet. Synthetic division. Okay, so everybody, you're going to love synthetic division because it's way quicker than long division. I will always use synthetic division over long division if I can. So if I ever have a linear factor or a linear thing that I'm dividing by, go to synthetic division. Okay, so once again, synthetic division just simplifies the long division process for dividing a linear expression. To use synthetic division, you write the coefficients, which this is just a process we're going to learn, so you'll understand it once we do it. So you'll write the coefficients, including the zeros, of a polynomial in standard form. You omit all the variables and exponents. And then it says, for the divisor, what you're dividing by, you reverse the sign of a. So this would be -2 that we're going to use. So what I like to say is I always go off to the side and say x plus 2 equals 0. So what is x? Subtract 2, right? So we're going to be using -2 in our synthetic division process. Okay, so you use the opposite of a. That's x minus a. So x minus -2. Do you get why x is -2? Okay, so everybody, you just got to go with it. It's just learning the process. So I go off because it's not going to mathematically make sense. Like, it's just a process, okay? So I go off to the side and I set it up like this. I put a -2 on the outside. I'm going to draw a little house, leaving myself some room in here. And now we're going to list the coefficients. Coefficients are what are in front of the x's in order. So you can't be missing like x cubed, x squared, x to the first, and then x to the 0. We're not missing anything. So if we were, we'd have to put in a 0 for what we're missing. But we're not missing anything. So we're just going to put the leading coefficients. This in front of x cubed is +1. This is +5 in x squared. And -1 in front of x. And -9 for our constant. Does everybody understand so far? But okay. So now what you're going to do, you can't ask why because I can't get into it right now. Sorry. But what you do is you drop this 1 straight down and put that, whatever that is, you put straight down. Now this is the process. You do whatever's down here times this. So what's 1 times -2? -2. Now we add straight down. What's 5 plus -2? 3. Now you multiply up. 3 times -2 is -6, and we add straight down. So that's -7, correct? -7 times -2. +14, and we add straight down. 5. Okay. So now we took it from degree 3. We divided it by degree 1, so it's going to be degree 2. So I just work backwards every time. This is our remainder. If that's our remainder, then this is our constant. If that's our constant, this is our x. So I'm just working my way up degree-wise. If this is x squared. So do you see how I went from remainder to constant to x squared? Okay, sweet. So now this is our polynomial. These are the coefficients. So we have 1x squared plus 3x minus 7, and we had a remainder of 5. So 5 out of x plus 2. So that is way quicker than long division. Yes. Oh yeah, it is +5, sorry. +5 over x plus 2. Just a different process to get to the same answer we got with long division. So once again, x plus 2 was not a factor of this, or else our remainder would have been 0. Want to do it again? Off your worksheet? You sure? One more? One more maybe? Okay, 16, here we go. Here's the important thing that you remember. We've got to set what we're dividing by. So you say, I'm going to use synthetic division because it's linear. So I'm going to go x minus 5 equals 0. We need to use the opposite. We'd add 5, so x equals 5. Okay, so we put a 5 on the outside of our house. Put it in your house. Here's the important thing, and people forget it. Degree 3, degree 2, degree 1, and constant. We have all of those there. If we were missing, like this x, negative 7x, we'd put in 1, negative 5, 0, 25. Does everybody understand? Okay, but we're not missing anything. So we have 1, negative 5, negative 7, and 25. We always drop this one down. Now you multiply up. 1 times 5 is 5. We add straight down. 0. 0 times 5 is 0. We add straight down, and that's a negative 7. Negative 7 times positive 5 is negative 35. And we add straight down, we get negative 10. We work backwards. This is our remainder. If that's our remainder, that's our constant. That's our x. That's our x squared. Once again, you need to end up 1 degree less than what you started with, and we did. So we got, when we divided x minus 5, we got x squared minus 7, and our remainder was negative 10, so minus 10 over x minus 5. So once again, x minus 5 was not a factor. Yes. If we had x squared minus 5, we would do long division, because it's not linear. Yes. Because we took, good question, I love this answer. We took something and we divided it down, so it's 1 degree smaller. Good question. We took our x cubed divided by x squared. Great questions. Okay, I won't do 31 if you're good, but notice on 31, aren't we missing x squared? We're going to have to put in a 0. Yep, we are going to end up, good point, we're going to end up with an x cubed. Okay, so same with 33. You sure you don't want me to do it? You put in, okay, 33. Yes. You'll use negative 4/3. And yes. I always use synthetic division if I'm dividing by a linear thing. Otherwise, long division. Yes. You still just drop that straight down. No, you drop that straight down. So they've been 1. So even if, this is a great question, everyone should listen. Even if this would have been 3x cubed, we would have dropped down the 3. Does that make sense? Yeah. Okay, let's do this one. 30, sorry, no, I didn't think this. Okay, 33. Oh, I don't know what the heck that is. Okay. All right, here we go. So I'm gonna use synthetic division 1. We set up our house, degree 5. In front of that is a 1. We're missing the degree 4, so 0. We're missing degree 3, 0. We're missing degree 2, 0. We're missing degree 1, 0. Negative 1. We drop whatever that is straight down. 1 times 1 is 1. Add straight down is 1. 1 times 1 is 1. We add straight down is 1. 1 times 1 is 1. We add straight down is 1. 1 times 1 is 1. We add straight down is 1. 1 times 1 is 1. We add straight down in 0. Oh, nice. This one was a factor. That's our remainder constant. X squared, x cubed, x to the 4th, which makes sense. Degree 5, we went down 1 degree. So x to the 4th plus x cubed plus x squared plus x plus 1 was our answer. Right? So we know that x minus 1, just a side note, times x to the 4th plus x cubed plus x squared plus x plus 1 equals our polynomial. That's not an 11. That was supposed to be a 1. Equals that polynomial. All right. Do 11 through 20. Go. Okay, so quickly, let's think about 25. I won't go through it all the way, but I don't want you to get home and be like lost. So 25, it says the expression for volume is equal to x cubed minus 13x plus 12 represents the volume of a rectangular safe in cubic feet. The length of the safe is x plus 4, so that's one of our factors, right? What linear expressions with integer coefficients could represent the other dimensions of the safe? So if we have something, volume is equal to, we have x cubed minus 13x plus 12. Don't we know that that's a length times a width times a height? We know that's what volume is. It told us the length is x plus 4. And so we need to know what the width is and height is. So wouldn't we just take this down, dividing it using negative, I'm going to use synthetic division. Couldn't we divide it down and make it quadratic? And then factor the quadratic to get the other linear factors, right? So let's use synthetic division. Make this degree 2 by using division. So we'll do 1. We're missing an x squared, right? 0, negative 13, and 12. We'll go through the process, and then we'll have something quadratic, right? Then once you have a quadratic, we know how to factor quadratic, and there's the other two factors. Does that make sense, everybody? I can't keep going. Does it? So when you get home, you get that once you do this division once, you're going to have a quadratic, and factor the quadratic, and you're going to get two factors. So then you'll know the other two factors. Yes. Yes. Yep. We will leave a factor. Questions? Okay. Next thing is called the remainder theorem. So basically what this says is, it sucks that it's so rushed today. I'm so sorry. So the remainder theorem provides a quick way to find the remainder of a polynomial of a long division or synthetic division problem. So basically what this is saying, guys, just look at number 1. When you took this polynomial and divided it by this polynomial, didn't we go through and get a remainder of 0? Now, guess what? If you plugged in negative 3 into the function x squared minus 13x minus 48, it's going to come out the same as your remainder. So once again, if I plug in negative 3 into the function, you see how the remainder comes out the same as this remainder. That will always happen. So, number 26, use synthetic division and the remainder theorem to find P of A. So this one didn't give us a factor, it gave us what A is. So if A equals 2, the factor would have been x minus 2, correct? Okay, but that's besides the point. It's giving us 2. So let's figure out what the remainder is going to be without doing synthetic division. You can just plug in 2 into the function, P of 2. So we have 3 times 2 cubed minus 4 times 2 squared minus 5 times 2 plus 1. If we calculate that, using our calculator, we get negative 1. So guess what? When we do synthetic division, we better get a remainder of negative 1. Let's quickly, so on these, it says use synthetic division and the remainder theorem to find P of A. So we found P of A by plugging in A. Now let's show that that's true by synthetic division. So we set up A, that 2 on the outside. We're not going to use the opposite because it wasn't a factor, right? It gave us A. Does that make sense? So we set up 2. Let's go through our process. We put a 3 in, a negative 4, a negative 5, a 1. Drop 3 straight down. 3 times 2 is 6. Add straight down is 2. 2 times 2 is 4. Add straight down is negative 1. Negative 1 times 2, negative 2. Add straight down is negative 1. Oh, our remainder was P of A. So we've shown that that works. Do you see how that works? No, you're going to show it. You'll just staple your work to your worksheet, and yes, you could just put that. Yeah, so look at number 7 through 9, 7 through 10. Let's see, there's 10 different ways you could do this, but it says determine whether each binomial is a factor. Isn't it true that if it is a factor, our remainder is 0? So we could go through and synthetically divide all of those, or we could just say on number 7, doesn't x equal negative 4? Couldn't we just plug in -4 into x cubed plus 3x squared minus 10x minus 24, and if it doesn't come out 0, our remainder wasn't 0? So that's, yeah, we'd say no. Does that make sense, everybody? The quicker way to check it, that will always work. So are we good, or do I need to do 28? We're all good, okay. Okay, so I think you guys understand this. It's on 21, it says, use synthetic division and the given factor to completely factor each. So when we take this and use synthetic division with -5 and then it's quadratic, then factor the quadratic, correct? So then when it says factor completely, you'll have answer x plus 5 times whatever two factors you get once you do synthetic division to a quadratic and then factor the quadratic. Do we all get how to do that? Sorry, it's such a short day. This video will be posted, so the rest of the worksheets, do it. So I'll give you the rest of the time, but they're all pretty basic like that. There's nothing super intense besides, and there's nothing. Okay? I will post the video if you need to watch it.